What's good, my analysts, and welcome back to the Analyzing PowerShell Payload series. This is actually going to be the last episode in the series, you guys. We've come a long way, but don't worry, we're going to be putting out more sick content in the future. We're just going to dive into some other topics, but we're just going to dive into what we're going to talk about today. So today we're going to be looking at PowerShell payloads that come from the Covenant C2 framework. So if you're not familiar what Covenant is or what a C2 framework even is, but C2 means command and control framework. So this would be adversaries or red team operators, what they are using to orchestrate their activities. Covenant is an entirely .NET based C2 framework. I think it was originally designed to just showcase the attack surface of .NET, but it's kind of matured into a a very robust C2 framework, and it's really extensible. It's actually my favorite one. Is the one that I like to use the most. But the interesting part about it is we do see it in the real world. Some adversaries and operators do use Covenant, and the payloads look a bit different, and they require a little bit of different analysis technique to extract that tactical intel. So you need to know how to do this, and it also can provide some context to your investigation. If you're able to see this payload and recognize it as Covenant, you know what the C2 framework is, and you can use that to drive further efforts in your response or investigation. So let's just jump right into it. I'm actually going to show you Covenant from the beginning here. If we go in, there's three components to establishing access to a system. So there is a listener, and this is, guys, guess what it does? It listens, and it's listening for connections from what is called a grunt. And a grunt is the term for whatever interactive access you have on a system. You're using the grunt to task it to do things. So think of grunts like beacons and Cobalt Strike. And the other component of that is a launcher. Guess what it does? It launches stuff. And what this is doing is assigning a payload using various built-in techniques. You can make your own. And it's doing to execute a bit of code to establish that connection. We're going to be looking at the default PowerShell one, because that's what this series is about. You can customize this a lot. So it is important to walk through the analysis kind of steps rather than doing things like keyword searching, because like I said before, after we generate this thing, you can actually modify the assembly code. So you can change this and add obfuscation and things like that. So you need to be able to think about the process to take it from .NET walk that back to try to pull back the tactical intel, just like we kind of did in the previous episode. So if we go like this, I'm just going to run this on my test system. On the other thing, you don't need to see it because all I'm doing is pressing enter on a box. And when we do that, we should see a grunt kind of register itself within the thing. So there we go. We have our grunt access. And we go like this, we can go to interactive, and I can run things. There's a bunch of built-in commands. These also can be customized, and you can interact with it just like it's a shell, and you can make it do it a bunch of different things, but that's not the point of what we're talking about today. Well, we want to look at what the actual payload is. So let's go into PowerShell. Let's grab this and put it into CyberChef to begin our analysis. All right. Right off the bat, we can see that it's PowerShell. There's our NOP. And saying command, ignore it, right? Because it's just launching a command. We come up with our with a keyword here, io.memory stream, and what this is right here, new object, is creating a new object, and it's saying of type io memory stream, and all that's doing probably a bunch of fancy stuff in the documentation, but all you need to think about that is when I see that, that's saying whatever this object is, whatever the data storage backing, do it in memory. Don't write anything to disk. Here's our command interpreter. So they put this all in one line. That's gross. So we know how to clean that up. They do another new object. Again, this is going to say we want to deflate this because it's going to be compressed. So, we've seen that a ton before. So we know that that's from base64 string as our other keyword. We know that there's probably going to be a decompress down the bottom. Again, we see IO memory stream and basically saying new object. To read this object, we want to decompress the data and also do a from base64 string on this blob of data, but keep it all in memory as our storage. And as we assumed, we have our decompress, creating our byte array. So it's going to be loading that assembly into a byte array and then invoking it at the end. It does some tricky stuff here. Basically, it's just reading the values into different objects to finally get it into O. right? And O was written as the first one as a memory only object. Write all that assembly into O, and then we have our keyword from last time, Reflection.Assembly load, so we know that it's .NET. We're gonna look at that in DnSpy, and then we have invoke, so it's running it. So basically, we've got to take a look at this base64 data, see what we can get from it. So we'll start in CyberChef just to, it's part of the process. And we have that, and we do list, and then from base64. And because it's compressed, well, there's nothing we can really do with it. It doesn't show us as a executable that we could download like last example because it's compressed. Now, we're going to have to use PowerShell to do the decompression because, and actually let me know in the comments down below if I'm wrong here, but I don't think that CyberChef has the ability to decompress using the native .NET decompression function. I don't think it has the same algorithm or whatever built into it, but that's okay because we can do it all in PowerShell. But first, we're going to do a find and replace on those new line or on those command interpreters, so we're not looking at just a bunch of stuff on one line. So we'll copy this into PowerShell. We can get rid of that first bit, and we can get rid of that at the end. And here's our Reflection.Assembly load. We'll comment that out just to be safe so we don't run it. And so like, what do we do with this, right? So if you can remember last episode, we had a bunch of assembly code in a variable, and what we did is write that to disk. We can take the same exact strategy here. Like they're doing fancy stuff to throw you off the scent, but really all we know is like there's a bunch of assembly instructions that are currently being stored in an array, and we know how to do that. So just to make things clean here, we're going to create a new variable that is referencing the copy and paste fail. Create a new variable called test, and we're going to take that O object and we're going to convert it to an array just like they do up here. And then we're going to write that out to a bin, right? Because it's a executable. And we say, oh, we're on a good track because the antivirus is yelling at me already. Now, if you remember in the last episode, we key in, there was a call of a specific function within the PowerShell payload itself that we use to drive our investigation. In this case, it's not as clear. It's not calling exactly some .NET function. And all we see is saying here, it's like, I'll convert it to an array and then call entry point and then invoke. So invoke means run. Entry point is actually a property on the assembly. And we can actually take a look at that by doing this. So what we're going to do is we're going to take that. We'll comment this out because we don't need to create a new file. And all we're going to do is take this. We're going to read this data into a variable, so it's stored there. And then we're going to do a format list on that object, which will basically let us look at all of the properties on it. It's not going to run it. It's just going to load it and dump out the properties. And from there, we can see that we can actually look at what the entry point is defined as. So we can use that to help in DnSpy, just like last time. We can look for main, basically. It says it loads main. So we're going to open this up. Test.bin. And here we say it's and Covenant does this randomly generated executable name. And if we go down into the main functions of this, we should see main, right? Boom. So we're going to start here. Now, hopefully you guys can see this. We look at this. We don't, like I said, I don't want anyone to ever feel like they need to know how to write in .NET to understand what we're doing here, because it's pretty straightforward. All we can say is like, okay, I don't know what any of this means, but I see something that says grunt stager. And it says new grunt stager. So that's a thing on the left-hand side, and we can even search for it using like search for assemblies, like in the last episode, but I see it. So I'm calling grunt stager. So let me click on grunt stager. Okay, this is all this does is saying I'm calling execute stager. And I see execute stager here on the left. So let me click on that. And when I get there, guys, then I get my C2 IP address automatically. And if I take this, we see from base 64, I can pop that into old CyberChef, and I'm going to get the user agent string from here and a session ID. So now I have more tactical intel, and there's a few other things you can pull from here. But that's how you extract the tactical intel from a Covenant payload.